We are the step-by-step interactive tree sculpture team.
My name is Eric Coley. I'm a mechanical engineer.
My name is Jesse Griffith. I'm a mechanical engineer.
My name is Emily Lewis. I'm a mechanical engineer.
And my name is Michael Williams. I'm also a mechanical engineer. And our project advisor is Dr. Bednarz.
All right, so step-by-step is an organization-based works fair that helps autistic adults within the community. They brought the idea for this project to Dr. Bednarz, who then presented it to our class, where we picked it up. So basically what they wanted us to do was to build an entirely interactive sculpture for their clients at their facility with multiple mechanical and musical components. They gave us free rein with design and concept. Working back and forth with them, we landed on a tree nature design. Our final design was a 6-foot tall tree, which we made out of steel. We have a base, which we made out of HDPE plastic, and then we have internal structure components made out of aluminum. So the basic scope for our projects that we have is we designed 4 mechanical components that we wanted to make sure were completely functional, and we also wanted to make sure the whole thing was structurally sound. These are images of our final projects at SBS's site. There's a video of all of our components working. Yeah, just a walk around with it. Yeah.
It was a little break as well.
Yeah. We have videos of each of our mechanical components working. See here, this is our weather vane component. This is our track system. Yeah, we're going to go more into detail about how they were all designed and prototype. This is our system. Okay, and this is our crane system. Okay.
So, one of the biggest changes from last semester was our CAD model. We had a lot of feedback from both the senior progress class and the last time we were here at the end of last semester for changes in the actual design. On the left is our original model, which has the longer branches and kind of just like a basic rundown of where we want everything to go, as well as just some kind of put together color selections, which is interesting because the blue did carry over to our final product. On the right, we have our prototype that we presented a few months ago in our senior products class, and one of the major changes in that is the actual branches. We decided to shorten them down just to kind of keep the footprint a little smaller around the actual 5-foot table section, as well as make it look a little more natural, adding more than just 4 branches at cardinal directions and some kind of standard sub-branch positions for those 1-inch parts that come out. The caps are also there, and the second model also has our final color selections of the brown for the tree, and the yellow for one of our sections, and blue for actually the entire structure. Some of the major differences between this CAD model and our actual final product are just some of the exact locations of where we welded these branches, and also some of the ways that the other parts are selected, as well as maybe a few things with how the mechanical components are explicitly mounted into the top, which is mostly true for the track section.
So for our budget was completely provided by SBS with an original goal of $2,500. So our first step in buying everything was for the structure. So that includes steel, plastic, and aluminum for the internal housing. So that ate up a good chunk of our budget. Then this semester when we came back in the winter, we chose to then focus on the mechanical components. So that included pulleys, shafts, V-belts, all that. And then when that all got ordered and we started testing, we then had to worry about the aesthetic started installing it about a week ago. We had to get all the hardware, fasteners, and everything so it would work properly and be structurally sound. So we ended up spending about $2,300, so we are still significantly in the budget.
So, as mentioned by Evan before, we had 4 mechanical components that we wanted to have fully functional by the end of the project. First of them is the racetrack system, which was arguably the most complicated, which had, as you can see there, that's one of our test sets, just making sure that the chain fits and works properly, where that is run by the chain and sprocket system with an extra pulley connection to have a crank handle that goes away from the track system to make sure that it can spin and not get in the way. Next up is the crane system, which you saw with the hanging bird that went up and down. That bird acts as a counterweight to keep our wire taut and straight to make sure that it can actually go up and down. And that is controlled by a bike pedal crank system that runs through the entire side and into the center of the tree with a pulley connection holding up the wire, which will coil around. After that is the weather vane system, which was the rooster that spun around, that had the handle on top, as well as an entire shaft going through the center, and a pulley being driven out of the steel tree in order for that to spin. And last, and kind of the simplest to install, was the set of series pulleys with the spinning flowers that you saw. That's just a set of 4 pulleys in a row, with one of them being the handle, 3 of them being the spinning flowers, with sets of double pulleys and V-belts tensioned at specific lengths to make sure that it's not the hardest to spin around, keeping the customer.
Prototyping phases, so we couldn't create a prototype per se, it's more so testing phases. So first was adhesive. So plastic, so it's 8 panels, it's not been on hot. So obviously we could bracket them together, but also we couldn't bracket all of them to be perfectly flush. So therefore we also had to figure out how we could get plastic other than bracketing. So that's one solution, but also we did more just for how everything was built. So we learned that HDPE plastic is a thermoplastic, meaning you can solder it together and it will not budge as long as you solder it properly. So that was one solution that we had for all the boxes that we made underneath the aluminum table, underneath and above the aluminum table, in order to keep the tabletop level alongside keeping the tree sound. Also, we had to worry about plastic to steel because we needed a topper for the weather vane in order to sit comfortably within the axle that we already had. So in order to do that, we tested high heat resistant epoxy and E6000. Hence the photos. We quickly learned that the high heat resistant epoxy, you need to put direct heat on it, and it just was not feasible for us to do it on site because we didn't have power a lot of the time. So therefore, we just chose with the E6000. You hold it, and it stuck perfectly. It's not going to budge. The next issue was going to be bracketry and supports. For the panels to be bracketed together, that was just small hinges, screw, and it was perfectly sound. And then paint. So our first issue was going to be how are we going to paint this huge steel plate, because we don't just want a gray tree. So I learned that Rust-Oleum paint is very good for metal and it adheres very well to metal. So we did that, and we also Rust-Oleum is also good for plastic, so we chose to use the same kind of paint for both. So the steel, the paint would adhere very well and it would not scratch off unless you put a lot of force into it, which no one should do for this project but then plastic was our issue. The plastic is very smooth, so when we initially tested plastic, it was spray paint instead of normal paint. So spray paint, it takes about 20 minutes to dry to the touch, but it's still going to be tacky for a day. So we had to do a lot of test pieces. So without sanding the plastic, it would scratch off immediately with no pressure needed. So then we decided to try sanding it with different grits. So we started with 80 grit, 120, 220, and 320 grit. So 80 grit did hold the best, but also it's a very coarse grit, meaning you're going to see it when you paint it, and we did not like the look, so we just chose 320 grit, which does just as good, and also it's finer grit, so it looks more aesthetically pleasing for the customer. So we did 2 coats of paint, then sealed, and it's perfectly fine.
So the prototyping for our mechanical systems, for our series pulley, we had to measure out where the pulleys were going to go, the distances between them, to see which tension for the V-belts was the best. So when the user interacted with the handle, testing physics to keep that in place. So that's where the that's attached to the feeds down from the bottom to another pulley. There's another piece of plastic on the interior holding that in place. For the crane system, this gave us a bit of trouble. We found that the cable feeding through the branch down the interior of the trunk, if it didn't have enough tension, it wouldn't wrap around the pulley properly. So we tested various different weights, and we found that around 180 grams was good for the weight that we needed. So that bird is hollow. So first we tried filling it with sand to get it to that weight, and it was almost not quite the right weight we needed. So we added a aluminum plate on the bottom, and that got us to a weight that worked properly. For the racetrack, similarly to the series pulley, we had to test the distances between the two sprockets, so the chain would have enough tension to actually turn when interacting with the handle. And that also has a pulley connected to it, so we have to test measurements for that as well.
All right, so the majority of this project, this is in two-part because of the different sites. We have the building construction. Building construction took the majority of our time with the setup. We did a lot of welding connections for the metal tree section as well as the aluminum tabletop, which was also a major change that we had to make from last semester. That would be the support structure underneath the actual table. That welding took a few days, and we actually had to end up redoing one of the welds for the table just to make sure that the heights matched and everything was set. Once that was ready, we didn't continue. Other than that, we also had all the major plastic cuts that had to be done. We had 8 separate side panels and 3 different panels for the top and bottom, as we had to split the 5-foot panel into 2 parts, just so that we could either both ship it and it would just be easier to manufacture. Other than that, we also have the mounting and installation, which we covered in the past few weeks here. Really the biggest concern was making sure that the concrete connections between the base and the bracket connections between the aluminum insert on there were perfectly sound, as we do not want this thing to be moving at all. And thus, we did that, we put it through plastic and the aluminum on all the sides to make sure it's solid, and as well as attach the panels, doors, top panel, and all the mechanical components.
Issues during the process, so this is a learning process for us as engineers. There's a lot of stuff that we learn from this. So first one I want to talk about was our concrete. So a big part of this project, before we could even start our installation, was they wanted a concrete base for it for us to be able to bolt into, and that was very weather dependent. So, and you guys know Pennsylvania weather has been pretty terrible. So for a while we weren't able to get concrete poured until last 2 Saturdays ago, and so that was a major holdup before we could even get to installation. Resources, so because this is an on-site build, we didn't have some power because SBS closes at 4 p.m., so we would have just time blocks where we would need to be able to use our power tools, and then after that we would just see what we can do, and if we couldn't, then our work day is over. And yeah, to be specific. So one thing was we found out during our installation process is you need concrete drill bits, because when you put a regular one into concrete and it gets really hot and it pulls up, it's going to be melting a little bit. You can't have that. So that was a problem. But we got concrete drill bit, concrete bolts. We fixed our problems. It's very secure now. Mechanical components securing in the pulley systems, because this was all on site, and because of the fact that building a prototype of this is difficult because, one, time constraints. We already spent money on our plastic and stuff like that, and being able to exactly know where everything is when we have an on-site build was a little bit difficult, so we had to do some of that, and the paint was scratch. And we were in accordance with the ethics of the 1.1, holding paramount safety, which is just making sure that we have all our caps in on the ends, making sure that all of the edges are round great video from Marshall. Mitch made this whole project for us. We would not be here without him. Thank you to Dr. B for being a great advisor. Thank you to Terry Chase for being the go-to. Also, thank you to SBS for trusting us with this kind of project. We really appreciate it. It was a big job. And finally, thank you to all of our families that actually helped us with this, because we called so many that, at times when we didn't have power, we needed a clutch, and they helped us. So thank you for that.
We'll get to other questions. Great job, team. You took a lot of the feedback from last semester's presentation to heart. I know there was a lot of folks that were concerned, would you get this done in time? And I think you really stepped up and worked really hard on this project. I know we were talking a little beforehand, so I have a two-part question. Is it fully functioning now? I know you were working 14-hour days all week. Is it functioning right now?
At the moment, all 3 out of our 4 systems are functional. The racetrack system provided a problem because we didn't anticipate the weights of the sprockets pulling it down. So it makes the pull at a certain angle, and it makes it really tight so it won't turn that well. So we need a socket. We need a socket to be able to pull the sprocket up that can support the weight. And when we get that, when the pulleys can be level, then our racetrack will work as intended. But right now it's falling off of the sprocket chain.
Okay, and all the teams encounter different challenges in their own way. Your team had a unique challenge that you can't just end the project with, okay, here's our proof of concept, here's our prototype showing that this may work in the future. You have an actual deliverable to the customer that they want to use this when you leave. So my second question, is it going to be done before you graduate?
Absolutely.
Yes.
We are going to finish it next week.
Yeah, next week or so.
Any other questions?
5%.
Question back in the back. Gotta walk.
Hey, hello.
So first of all, I just want to, I know it's step by step, we have Susie O'Donnell, we have a couple of us here, and I think we have someone down in the front or closer to the front who will actually be working with the individuals that will be using this sculpture. So first of all, I just want to say thank you to Wills for taking on this project and realizing that all careers, we certainly need to support our community, we certainly need to understand and to provide supports for individuals with unique needs. So with that, I would also like to say thank you for the relationship building that you've done with members of the step-by-step team to understand the individuals that will be looking at this and using it in their day. We certainly hope for it to be a long-standing asset and aspect of our garden area where individuals can go out and decompress and just kind of enjoy themselves with it. So just want to say thank you again for taking on this project, and we hope for many more. Thank you.
Hi, so I have a question as far as safety. With this population, some individuals do exhibit repetitive behaviors. So the components like the bird, the wings, have you done repetitive motion testing to make sure those pieces will not break off and it could be a hazard?
So the wings on the bird are on a spring, so they're pretty flexible, so they're not going to break off. Especially with the force that they're doing it, it's not going up at rapidly, so it's not going to be pulling down or up to break the spring because of the smooth movement from the crane. It should be
Okay, because I've worked with this population, so as far as are they I'm sure they'll be supervised, but
Can they rip it off?
just twisting motions or repetitive
Yeah.
a concern as
Yeah.
far as
It's designed for that, yeah. Thank you.
And I think we had talked that you were going to have a complete user's manual with all the parts if anything does break.
Yeah.
Step by step could replace any components.
Yep.
Yeah, before the project.
We're gonna have a complete parts list of where each of our vendors, and so they could go out and replace anything.
Any other questions?
public project. Is there an inspection required?
I reached out personally to the zoning office of Wilkes-Barre, and we did not need any permits or anything for the installation. So, yeah.
But is that an inspection?
They didn't say that we needed anything inspected or anything like that. They said that because of the height, that we sent them images of all of our CAD models, and they said that it should be.
All right, I've got 2 questions for you. My first is concerning metal interaction. So I know that you've discussed using an aluminum base, and then your more so central structure is made out of steel. Steel and aluminum are not really intended to go together, so I'm curious as to how you combated this.
Zinc plated.
So all of our brackets that are aluminum are not directly touching the steel, and everything that is aluminum is zinc plated, which we researched that should be
good.
Yeah.
Anti-corrosion.
anti-corrosion.
All right, and then just finally, because it wasn't mentioned, I assume that you guys have taken this into account, but obviously with this being around autistic personnel, there's got to be, a high degree of safety consideration. So you ensure that all of your edges are deburred, rounded off, ensure that everything like that is safe.
Yep.
Yes.
Okay.
Thank you.
Any other?
Did you?
Did you take into account the pulleys and the belts with the slot at the top of the table that someone can put their finger in there and get caught in the pulley?
Yeah, we
Yeah.
covered those.
Yeah.
With like a top on top of it, we have a long piece of plastic that like a wall, because we also did cut the tabletop into 2 separate sections to make it easier. So anywhere where there is a gap, either was caulked on the sides or on the top, the main seam that you would have seen was connected by 2 plastic pieces, and they were screwed in to connect. So there's no gap for them to sink their fingers in, and also for the racetrack, I know you probably saw like the big hole in there. That's designed to be smaller. They're also being covered. Thank you. Sorry.
Very good job. Who was the artistic director?
Honestly, it's my
Two of us, we all
Because I feel this piece you can put in Roma can work pretty well. I mean, I like the abstract of the design. It's almost like Picasso kind of style. So very good job on that. Seriously, I mean, I like the artistic aspect of it. The abstract and the but I do have one serious question, which is mentioned, which is the fingers, the popping the pulley, and so just make sure you take care of all those things and make sure the user are not able to reach those areas, and the safety is extremely. Yeah, and also like the weather, how, what would you expect this to? How many years? Like rusty and other things. Did you do any kind of study on that? Because is an umbrella actually necessary or whatever?
We sealed all the metal parts of it, just so that they're completely weather resistant, as well as the paint does a little bit of that top of the process, especially.
Okay. So one final question, which is, did you guys ever do a little bit of study on autism and then take that, how did that affect your design?
So we both have family members that are on the spectrum and stuff. So when, like, especially for us, safety concerns are very important. So we did consider them, and even Emily asked her brother questions.
Yeah, I have 2 brothers that are on the spectrum, and so being in this community is like part of my life. And I have done research.
All right, thank you.
Okay, one more?
Would you classify this as playground equipment?
Yeah.
The plastic is playground grade plastic.
Okay, so there's a whole ton of standards associated with playground equipment and so on. Okay, so you need to look into those. At the same time, I think in your manual, you might want to add, as part of the maintenance of the system, because you should have a maintenance section in there, which would be regular inspection, and you want to walk somebody through that inspection process or whatever that is. Okay, so those are they're just comments of what you should make sure you put into your documentation that you're going to provide to the customer, because they're going to be responsible for making sure it's maintainable and safe once you've delivered it to them. Okay, so put in an inspection process and procedure, what is good, what is classified as bad, and so on and so forth. Okay, so those are the things you need to look at. At the same time, you might want to pull down and look for what are the inspection standards required for playground equipment. This is not a swing set, this is not a sliding board.
Yeah.
Okay, this is a stationary piece of equipment. Okay, but you still need to follow the rules.
Oh, thanks.
Yeah.
Yeah, we'll take that into account. Thank you.
Thank you very much, team.